Hello 108 class, Mr. McHugh back here with you. Going to tackle section 10.5 as we continue our work here with application problems on page 4. And this example number 3, which is based on page 605 out of your book. H3O is a hydronium ion, and this time we're going to find that for your fellow chemistry student, and that's because they're going to give you the pH this time, and it's 6.5 in this problem. So if you're given a pH of 6.5, what is the hydronium ion? Now remember, we used X for mathematics just to make it easy on us. Okay, so you're just kind of going reverse order here, so take your time. One of the things is, you want to solve for X. Okay, you're like, well, how should I do that? First thing is, you see that negative right here? You want to deal with that. You need to get a positive log. So multiply everything by -1 on both sides of the equations, aka switch the signs. So now you've got -6.5 equals log of X. Okay, now from here you go, I got a calculator and I got log button, but when the X is in the result, you need to transform this into exponent form. What I mean by that is, what's the definition of a log? Now I took the log, I wrote the left side, right side, I switched it here just to make it easy for me. So one way to do it is to say this is log of base 10. If you don't see the log, that's base 10, that's what we're learning. Result X equals exponent -6.5. So write the base, which is 10, it's assumed, exponent is -6.5, and that equals the result. Okay, now an alternate way to do this, in essence, you're going to see me, I'm just going to flop the left side and the right side of the equal sign, but I like to look at this, and sometimes I like to say drop down the result. Say X equals the base, which is assumed to be 10, raised to the exponent, which is -6.5. Okay, so there you go. That's going to be your answer. Excuse me, Paul, I apologize for that. You are going to use the calculator and put 10 raised to the -6.5, and you will get an answer on your calculator of 0.1234566. 6 zeros, 316. Okay, my math lab will tell you they want it in scientific notation. Okay, so we got to go back and use some of that work from chapter 5. We want to write an answer that is in, let's see if you can help me out. Remember, use your aid, and you want to move this 7 places. You're counting 1, 2, 3, 4, 5, 6, 7 places, so 3.16 times 10 to the what? We're going from what? Small to a big number, so we got to go reverse. Remember the clutch? Big to small on the exponent, so I would go something smaller than 0, aka -7. And there's your answer. Okay, that should help you out a little bit. Now let's go ahead and move on to example 4 here. We're talking about measurement of loudness of sounds, dBs. Hopefully everybody's heard that. Decibels, off the top of my head, I don't know why they use the little letter D and capital B, but dBs are used for sound. The loudness of sound. I could whisper to you and you could barely hear me, or I could scream and you could be next to a lawnmower, or if you ever go by a jet, or if you've been to rock concerts, you know, you come out of that, listen for a couple hours, your eardrums are ringing. Okay, so that loudness, we got to worry about that. You take too much constant pounding of loud noise, it'll affect your hearing. Okay, so with that said, the formula for figuring out the loudness of music, or of sound, not just music, is D for loudness of the music. I keep saying music. Sound. D is equal to 10 times log of I, which is the intensity of the sound, divided by the threshold of sound. That's where we can hear it. Where humans can hear. I guess you guys probably know dogs have better hearing than us. They can hear things a lot lower sounding than we can. Okay, now, so these problems start on example 4. Notice here, by the way, class, I forgot to mention this. Look at this little hint. Let me come back up here. These problems here, we're getting to the end of the semester. It's getting a little crazy. I'm trying to help everybody. Should you know how to do example number 3 and 4? Oh, most definitely you should do example number 3. You're going to see it both where? Test and a quiz. And this example you're going to see number 4 on the quiz. Okay, one caution. Okay, this example is on page 606. And one little detail, just so I don't drive you crazy, this is 11 is from the old version. The new version in your book has it times 10 to the 9th they picked. Make sure you realize that my answer will not match the book here. Okay, mine's from the older version. Okay, so if we are told that the intensity of sound, I, excuse me again, is given as 3.162. Now the book says times 10 to the 9th. They used to have it times 10 to the 11th. Times I sub O. This is a little weird way to do this, but okay, we'll go with the flow here for a second. And they ask us find the decibel, the dB or the decibel level of that. If the intensity of sound is 3.162, you're going to turn around and write the equation. We're going to solve for D. 10 times the log, log. Notice the base is 10, not written, so it's a natural log. I is 3.162 times 10 to the 0, so we drop that in, divided by I sub 0 from here. Okay, now why they go through make you jump through this hoops? What's anything divided by itself, class? 1. So you're left with 10 times the log of 3.162 times 10 to the 11th. Okay, here's where you're going to start doing your work. Next thing, you got the product rule over here. Multiplication, you split them up to addition, so you're going from multiplication, you're going to split it up into addition. Here's your 10 on the outside, log of 3.162 plus the log base 10 of 10 raised to the 11th. And what's happening over here, you get that outside the exponent drops down out front, so you got 11. That's where this 11 came from, plus the actual log on your calculator. Here you use your calculator, type in log, type in 3.162 equal sign, and you'll get 4.499. Okay, does everybody see that? Here's where you're using your calculator. Now, last step, add 11 to that, so take 11.499 times 10, and they round it up to 115 decibels. Okay, now the last question is, what range are you between? This is interesting. Conversation between two people around 60 dBs. Lawnmower while you're cutting the grass, about 90. Go to a rock concert, you're up to 115, so this is what, pretty loud. Getting close to a rock concert. Ever go by the Boise airport, it'd be right up next to jets taking off. That's 140. And if you ever have seen one of the space shuttles launched, or if you could be right up against it, which of course you're not allowed to, that would be 180 dBs. Mighty loud. Okay, Mr. McHugh here. We are cruising through page 4, so let's give ourselves a check mark here. I hope everybody's doing okay with these. Again, take advantage of the homework. Make sure you understand these. You'll see that on a quiz. Okay, we got 2 more pages to go. We're not done yet, so we're going to keep working here. We're going to go to natural logarithms now, cover the second half of this section. Okay, till then, take care. Bye.